Okay, for question number 1, I have the shaded region is bounded by the square root of x. The square root of x shape we should know is this one right here. And then e is an exponential function, but it's a negative, so it's a decaying exponential. That's this function. And then the vertical line y equals 1 right here. For this region is the base of the solid. And for this solid, each cross-section is perpendicular to the x-axis. So when you draw it, you're just going to make sure you draw between the top and the bottom function. I like a nice drawing, like a nice rectangle here of thickness that is dx. And there's no need for any white space in these kinds of problems. You're not spinning around an axis like a volume of revolution. So just go from the shaded region of the top and the bottom. Then this space right here, I'm going to draw what shape it's creating. So I'm going to turn it on its side, that shaded line, and make it 3D. Coming out of the paper, it says is a rectangle with the height 5 times the base. Well, I can't draw it, I guess 5 times exactly, but this is the idea that it's a 3D rectangle here. And there's a bunch of these rectangles, but what this represents right here is the base of the rectangle at the bottom right here. Okay, so then to set this integral up, the area of the rectangle's length times width. And so this, I need to get this length right here, or base, I should say, is this line right here. So to find this length of the base is always top minus bottom. So the top was the square root x minus the bottom is e to the negative 3x. So then over here, I'll just label this is square root x minus e to the negative 3x. Then the height going up and down is 5 times that amount. So this would be, for the height here, would be 4 times that top minus bottom line. All right, so then when we put it in an integral, it would be the base piece, which is square root x minus negative 3 to the x, times the height, which is 4 times that, and we could just simplify this just a little bit. Since there's 2 of these quantities here, we can just put 4 times this quantity squared. Now we do need to find the integral upper and lower limit. So we have to find, starting where our first rectangle would be, which would be right here, all the way to the last rectangle over here. Well, we can see the last rectangle ends at 1, but this one, we don't know where that value is until we find the intersection. So we'll need the calculator, and we will have to graph those 2 functions and find the intersection. Looks like my window might be bad. So to change my window, I'm going to just go zoom standard. And let's say I wanted to zoom in on that a little bit better. I'll go zoom box, this first choice here. Move my cursor up to the corner of the box that I'd like to zoom into, press enter, and then I scroll over and down, right, and then down, and then whatever box I create here, that will be my new window. And obviously I can see exactly where I'm looking for now. There's my intersection. So I'll do second trace, intersect, go to the left of that point, enter, then push to the right, enter. And so that value is 0.23873. I'm not going to round too soon here because this is not the final answer. So I want to keep a good, I got at least 4 decimal places in here. I could even do more. All right. Now I'm going to put this into my calculator to integrate this. Now a little trick you can use here is there's a little technique with the calculator. Since I put in y1, I put this in for y1, and then I put this in for y2. What I can do is back in my main screen, I'm going to set up the integral by pressing math and then integral from 2.2387734 up to 1. Then over here, I'd put 4 times, and then the quantity. I could retype these equations in, and these are actually not that difficult to type in, but I could also do this little technique. I press vars, and then go to the second one here, y vars function, and then I want to do the square root of x first, and that square root of x I said was y1. So I can press enter, minus y2, vars again. So press that vars button, go to the right function, and then minus y2. Then I have to make sure that this is squared. So you needed another set of parentheses here so that this y1 minus y2 gets squared. And then that will give me my answer. And of course, you could just type those equations in, but on a problem that gets, really long, this y2 minus y1 thing is really helpful. Just make sure that these equations in y1 and y2 are the right order. Otherwise, you got to go y2 minus y1, whatever it might be.